antiderivatives, or what we refer to as integration. Now, in a typical differentiation problem, we are given a function f of x, and we are asked to compute what? The derivative of the function, which is what? F prime of x. Okay. On the other hand, in a typical anti-differentiation problem, we are given the derivative of the function f prime of x, and we are asked to compute the original function, which is what? F of x. For example, if we are given that dy over dx is equal to 3x squared, we are required to find what? To find y of x. So we are given the derivative of some function y of x which we do not know, and that derivative is what? 3x squared. In antiderivatives, we are interested in knowing the function whose derivative is what? 3x squared. So we have dy dx, which is f prime of x, equal to 3x squared, and we are asked to find y of x. What this means is this: we are required to find the function y of x such that when that function is differentiated, we have 3x squared. Now, it is obvious that that function y of x is nothing but what? X cubed. Yes, x cubed, because if we differentiate x cubed, dy dx of x cubed is what? 3x squared. So we say that the antiderivative of 3x squared with respect to x is what? Is x cubed. Dy dx of 3x squared, you are asked to find the antiderivative of this function. What it simply means is find a function whose derivative is 3x squared. And in this case, we know that if y of x is equal to x cubed, then the derivative of x cubed, which is dy dx, is nothing but what? 3x squared. So we say once again that the antiderivative of this function 3x squared is what? X cubed. And while we say on the other hand that the derivative of the function x cubed is what? 3x squared. So this shows us that what? Antiderivative is nothing but the reverse process of derivative. That is to say, if y is equal to x cubed and you're asked to find the derivative of y, which is dy dx, and what would that be? That would be 3x squared. In antiderivative, you are now asked to find the antiderivative of the function 3x squared, and that gives you what? X cubed. So derivative and antiderivative are just reverse processes. Let us observe something further about this. 1. If y of x is equal to x cubed plus 2, what will be dy dx? Our dy dx will be what? Let's differentiate this function. It will be 3x squared. 3x squared. 2 is a constant. So if we differentiate a constant, we get 0. So we have 3x squared. Let us also look at another function, y of x equal to x cubed minus 8. What happens here again? If we differentiate this function dy dx, once again, we get 3x squared. And minus 8 is a constant. And when we differentiate a constant, we get what? 0. What do we see here? We observe that the function y of x equal to x cubed is not the only function whose derivative is 3x squared. As a matter of fact, the function x cubed plus 2 has the same derivative as x cubed, which is 3x squared. The function again x cubed minus 8 has the same derivative as x cubed, which is what? 3x squared. And if you follow what is happening here, you observe that, in fact, there are infinitely many of such functions with the derivative 3x squared. Let us take one more. Y of x equal to x cubed plus 10. If you differentiate this function x cubed plus 10, what do you get? You get 3x squared again. So, this is because that means that there is a constant c such that whenever you differentiate d dx of the function x cubed plus c, we get 3x squared. Now, this c represents the constant. In the first case, we have here x cubed. Here, obviously, our c is 0. In the second case, y of x equal to x cubed plus 2. Our c here is 2. In the third case, our c here is negative 8. And in the fourth case, our c here is 10. So, the derivative of the function x cubed plus c, where this c stands for any of these constants, is equal to what? 3x squared. In other words, if we are asked to find the antiderivative of this function, 3x squared, it would not be proper to say that the antiderivative of 3x squared is y of x equal to x cubed, like we had earlier said here. Because we have seen here that x cubed is not the only function whose derivative is 3x squared. So we will now say that the antiderivative, of the function 3x squared is x cubed plus what? Plus c. X cubed plus c, where the c is called a constant of what? Integration. In our later classes, we shall learn how to establish what value this c holds. So, in terms of notation, we would say that the integral of the function 3x squared, or the function 3x squared, we say the x means with respect to x is equal to what? X cubed plus c. And I hope the reason why this c appears is obvious from this illustration. For the fact that when you differentiate the function x cubed, there are many functions. There is a family of functions whose derivative is what? X cubed. So, since you do not know if the function we are talking about is x cubed plus 2, x cubed minus 8, x cubed plus 10, or any other one in that family, we simply say plus what? C. And later on, we shall learn how to determine the value of c. So, integration generally, so when you try to find the antiderivative of a function, like this function 3x squared, with respect to x, we now say that you are integrating the function. So, the process of finding the antiderivative of a certain function is what we refer to as what? As integration. So here we would read that the integral, this elongated s symbol is letter s, but now it's elongated, is like this. So we say that the integral of the function 3x squared dx. So we read as the integral of 3x squared with respect to x is equal to what? X cubed plus c, where c is called a constant of what? Integration. And of course, we shall see later that there are really two classes of these integrals. We have the definite integrals and the indefinite what? Integrals. So for the indefinite integrals, we see that there are no limits. The limit of integration here are not known. But for definite integrals, we shall have limits, say, from a to b. So when we get here, we shall discuss and learn the different methods of used in integrating certain classes of what? Of functions. So don't forget to like and subscribe to this channel so that you get updates as we come up with different videos.